Let's go ahead and get started. I'll grab the agenda here for the call. I think the main thing that we'll discuss for the day is just settling the gas pricing. I think that was like kind of the big open question for this EIP and Pectra. But then I think settling the gas pricing opens up a lot of different questions attached. There was also a proposal to remove the mole precompiles and instead use the MSM to signal mole of just one element rather than multiple. So yeah, I guess to kick us off, there was some discussion already on the issue around these different, yeah, I guess gas prices for things. Jared, you had a recommendation here. Do you want to give us a little context on your thinking?
Yeah, sure. So basically the the argument I'm making is that if we're going to change the MSM gas model, we might as well reprice other precompiles that are pretty simple to reason about. And I came up with uh, just a suggestion to reprice those, just an example repricing using the performance of EC Recover, scaling them to the performance of EC Recover and the Geth implementation of EC Recover. So, um, yeah.
Is there a reason for EC recover? Like, is that how we thought about the alt BN curve?
Um, I'm not sure about that one in particular, but I do know that when they repriced the ModXP precompiles, it was used in the EIP as a justification, and uh, I don't know, it's I would say with lack of access to a bunch of different benchmarking machines from my side, it's the um, easiest way for me to make pricing suggestions.
Yeah,
Uh,
that makes sense. I guess Barnabas. Oh, I mean, you have something to say?
Yeah, I made some suggestion in April back on the benchmark I had based on Constantine. One of the easy repricing to do is make sure that the KZG precompile and the EIP-2537 have the same price for the pairing. Like this is it's the same operation basically, so they should be the same. And actually, currently there is like 20,000 gas of difference or 10,000 gas of difference. And then yeah, I mean, I've put a link with my benchmark on my own machines to give you a sense, like when it's using the same library for everything, because when you use Geth, for example, it's implemented, EC Recover is implemented in SegP26K1, and things are implemented in other languages or manner. So I guess this will give you a better holistic view of the price.
Okay, thanks. Hmm. Well, okay. I mean, yeah, and I see you have here, you have a section called out with subgroup checks. I thought I saw somewhere. Yeah, okay. I mean, I guess that's like one place to start. So we had gone back and forth on this, and I believe where we settled last was that we would have them where appropriate, which I think is like most of the precompiles. Does anyone want to argue for something else?
I'm sorry, I missed that last bit, to be honest. Are you saying that we would price pairing specific to
Well, it would apply to like I think most of the precompiles. So essentially like so yeah, there's this question of I can pass in like say the points can be like U256 and or like a UNH256. So it turns out that, you know, for all valid integers in that range, only a subset are, you know, work or make sense with the actual way the curves are constructed. And so, you know, what usually is done, and maybe someone can correct me if I'm wrong, but usually what's done is if you have some number, you do a subgroup check, either to say, hey, this is an okay number to proceed with, or I feel like there's also like a reduction you can do. But there's like a security issue if you allow sort of quote bad inputs. And so then the question is like for the precompiles that we exposed to everyone on mainnet, you know, do we want to prefer the security and or like the safety of this? And the trade-off then is like these subgroup checks do add computation. So, you know, they are, you know, more than zero expensive. So there's sort of like a security versus cost trade-off to navigate. And, you know, I feel like we had said a few months ago, basically, hey, like, let's go for security. So even if it's more expensive, you know, the misuse is, you know, the risk of misuse is much, much lower this way.
And potentially the risk of consensus failure. If these edge
Yeah,
cases are handled differently.
I don't think it would be consensus failure. Like, this is something we can test for. And it's more like, you know, the clients would all do the same thing. It's just not what the user wants.
Oops, this working?
Yeah, we hear you, Kev.
Oh, sorry. Yeah, I guess it just depends on who the user is. Once we sort of say this is the user, then it's sort of easy to say whether we should include them or not. Does anyone have a candidate sort of user / use cases?
Well, there is obviously rollups because they will be likely the main consumer of cryptography. And we can assume that they will audit their contract and that they know what they're doing. But yeah.
Right. Is there any other use cases or users? Because rollups, we can assume that they're going to do the subgroup checks.
Alex mentioned validating BLS signatures from validators, so I guess that involves bridges.
Yeah, and I mean, I just feel like there's a whole host of applications you can imagine that come
Anything
down
that
to validating, you know, what validators have signed over. So those to me, I think are like the two big ones. But also, yeah, I guess that's almost another one is like bridges from other chains as well. Could imagine using this.
possibly people like I guess Flashbots or EigenLayer if they want to do restaking and verifying some of the consensus
Right.
stuff.
Yeah. So yeah, and point being is just like, okay, can we validate snarks in like a nice way? That would be the real use case. And then can we validate BLS signatures in a nice way? And I think those are like kind of the two buckets of things. I don't know. Like what I would say is start from let's make like assume the most sort of secure thing we can, aka like expose the safest API and see what it costs. If it's, you know, way too expensive for anyone, then we can evaluate like ways to make it cheaper, probably at the same time making it less safe. But even with rollups, it's like, okay, like if it's only going to cost like a little bit extra gas to do the subcheck groups, the subgroup checks for them, like I don't see why we wouldn't just go ahead and do that.
I think the argument is that if you call the precompiles multiple times, you're doing redundant subgroup checks.
Exactly. That's the, and also in my opinion the most important reason that it should be possible to turn off the subgroup check for these precompiles, because in other case, in my opinion, in in a lot of cases it will be just useless because they will be paying for unnecessary checks. So
Right.
So should we, like, there are two ways if we want to turn this off, assuming we're okay with the security implication. One way is to create a separate subgroup check opcodes, what precompiles. Or the other way would be to add a flag, like a Boolean, to say a skip subgroup check, for example. Which
Yeah,
means it forces people to think about it.
yeah, this will complicate a little bit the gas model for this precompile, but that's one of the flag also can be added to not in a globally to all the sets, all the points in the set, but also for each point specifically. So with additional flag, for example, using the spare bits at the beginning of the point. But of the point, yeah.
Just to be clear, are we only talking about removing subgroup checks for the MSM?
I think it's also scalar multiplication.
Yeah, I agree.
So,
As well.
so when I did some benchmarking on I think it was Friday, just looking at Gnark, the cost to perform the subgroup checks and then the GLV multiplication was not all that much more than doing the whatever the naive like double and add method that can take any input. So it seems like there should be no reason to remove the subgroup checks on scalar mole. Like there's and this is just one library, of course, but yeah, it just doesn't seem like we gain anything from removing them for scalar mole from scalar mole.
Yeah, on the other, I also made the benchmarks with for the multiplication for G1 and G2, and the maybe not naive method, but the method with windowing, and without subgroup check, comparing to the method with using GLV and subgroup check, which is required for GLV. So I get the same results or very similar for G1 and for G2 in using, I'm talking about the BLST library. And for G2, even so for G2, the GLS algorithm is used there for G2, but basically it was much faster, and even with subgroup check, it was faster than the naive method without subgroup check. I mean, by naive method, I mean the window method, which is subgroup check resistance.
Right. So I think the only reason to have the subgroup check on the scalar model will be for consistency. So if you do MSM with one input and then you do a scalar model, it may give you different results depending on like if one of them has a subgroup check and the other doesn't. I'm not sure if this is important for people.
Yeah, I mean, it seems good to have the ability to disable the subgroup checks, but I think we need to ensure that we're going to have a deterministic result with all the different implementations that we have. If I understand correctly, if some implementations might use endomorphism acceleration and some might not. So yeah, so I think we just need to try this.
It's not safe to use endomorphism without subgroup checks. So when I implemented the precompile, when subgroup check were required, I use endomorphism, and if it's not, I just don't use them. And in MSM, well, I don't think people are doing MSM of over 1,000 points in the EVM, but who knows? Endomorphism are not worth it in my benchmarks. And Gnark does not use them at all for MSM anyway.
Yeah, I'm not 100% sure, but also BLSD doesn't use the endomorphism acceleration for MSM at all. It is just a Pippenger algorithm for windowing. So it should work on whatever points from the curve you take.
So I guess, do people agree with the consistency issue, and is it an issue at all? So essentially, if the scalar multiplication has the subgroup check, it's inconsistent with an MSM of size 1 if the MSM doesn't have a subgroup check.
We could combine this with the other proposal of just getting rid of the mul to simplify things and just using MSM.
Right.
Mm.
In that case, that would be the same as having the scalar mul, but without the subgroup check and not using the endomorphism. It's just that we have one less precompile. Because internally, I think EVM1, they just did an if statement on the MSM size, and then they're just doing a scalar mul.
Yeah, I think I'm not sure if Pavel can hear us now because yeah, so that's a proposal made by Pavel to change this precompiles list and remove the moles, and we have some I think draft PR which implements the multiplication using just MSM with 1 point.
Right. So does anyone, I guess the higher level question, does anyone think that MSM of size 1 and a scalar mul should be different?
They should give the same result and same error message. But I don't know if removing this, like the simple scalar mul is useful for audit code readability. You don't have to double check how many inputs you have when you are reading the code. So not too sure if removing it is worth it.
Right. I'm not super convinced on removing it either. But yeah, so I think everyone sort of agrees that MSM of size 1 should be equal to a scalar mul of size, a scalar mul, which means that if we keep the subgroup check plus GLV for scalar mul, then we'll need to add it for MSM as well, or at least for MSM of size 1.
When you say same result, I assume you're talking about the actual output, but also are you talking about performance or like costs?
No, I
Just
think
the error.
it's if you have an error because something is not in the proper subgroup, both the MSM and the scalar mul of size 1 should give the error. But it's not the case if one has subgroup checks and the other does not.
Right. Would the scalar mul cost the same as the MSM with input 1?
Yeah, I agree on that. That it should be the same cost, exactly the same errors.
Right. So if we keep subgroup checks, then the MSM will have an if statement that that does the GLV endomorphism plus the subgroup check. If we remove subgroup check, then I think the MSM would probably still have to have an if statement, but it just does normal scalar multiplication. Because Pippenger of size 1 is probably going to be a bit more expensive than just doing a regular scalar model? I haven't checked.
It's not really that much more expensive. I don't have a special path in Constantine, and the speed is the same.
Okay, so then we probably don't need an if statement if
But
there's no
this is
subgroup.
like implementation detail. People can do whatever they want for
Well, it
this.
wouldn't matter. Yeah, I mean, but we need to, like, the gas cost have to make sense.
Yeah.
Mm-hmm. Okay, cool. Yeah, so if we remove or keep them, then they'll be the same. It's just all about the behavior. And I think most people agree they should be the same behavior. So that goes to Jared's question on why we want to, what's the point of sort of keeping the GLV plus subgroup versus not having it? It's whether we want the MSM to have subgroup checks or not.
Right. So if let's say I'm like you know, a roll up or just maybe some user, like what does it look like for me to do the subgroup check myself? Is this something I do off chain? And then does it matter? Like, would I ever want to like prove on chain that I was inside the subgroup? I guess is the question.
So it's for most, it's context specific, depending on whether you trust the input. If you trust the input, then you can have a reasonable, then you will know if it's like in the subgroup or not. If you don't, you probably want to do it at the beginning of your computation and then not do it again because all the operations should keep you in the subgroup.
Mm-hmm. And so how expensive would it be to do on chain?
The subgroup check.
Yeah.
I'm not sure we have any gas pricings for them at the moment, but it depends on like how many points you have as well.
I haven't benchmarked the subgroup checks alone, but it does make like a very significant difference to the overall gas costs. Wait, so Kev, do I understand correctly? So you're saying that it would be easier to keep them the subgroup checks for scalar because they're used by more implementations, and so we'd have to keep them for MSM of size 1.
Oh, sorry. What I was saying is that if you look at scalar mul in isolation, it doesn't really make sense to remove the subgroup check because without the subgroup check, you have this sort of basic scalar mul algorithm that's roughly the same performance as with the subgroup check plus the optimization. But if you look at the consistency between scalar mul and MSM, if you keep subgroup check for scalar mul, then it makes sense to keep it for the MSM. But we've just seen that keeping it for MSM is actually adding a lot of cost.
And is that cost because we're doing like, is there like we're still only doing the subgroup check once per input, right? It's not that we do it like many times.
Yeah, but the thing is, MSM is sublinear. But if you the subgroup check, you have to do 1 per point, so it's linear if you do the subgroup check. So the slowdown is big, but it depends on the size of input. Like I don't know if there is enough gas costs to do 1,000 points in MSM, which would be noticeable, like the difference between linear and sublinear.
I think for G1, the absolute worst test case that either Martin or Marius was able to come up with that would fit within a 10 million block gas limit was 4,800 points, but that doesn't factor the cost to set up the call to the precompile. So it seems like maybe 1,000 could be doable, but
Right. I mean, do we have a sense of like, you know, let's say I have like a nice snark scheme that's relatively modern. Do we have a sense of how many points I would need to verify?
One of the things that might use this for verification would be maybe the vertical trees. I'm not too sure, but do they use this?
Vertical tree uses IPA. I would assume that there would be a precompile for it if we was to do verification of it. For most snarks, so for graph 16, there's not a
It's
lot of
pairing.
points. Yeah, there's not a lot of points anyway, so it just gets limited by pairings for Plonk.
I guess that's my question is how realistic is it going to be for a user to come and need to verify, feed thousands of points into the MSM?
Oh, I see. It's a good point. Not sure. If I check just normal Plonk, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Like about 16. Like we can just say 20, MSM of size 20 for like regular Plonk.
Okay.
So I don't think you'll get up to like 1,000.
Right. And I guess my other question then is like, is it actually, so I guess, yeah, like let's assume we keep subgroup checks for everything. There's no way to toggle them off or on. Like, is it actually like for inputs that people are going to use, say in the next, I don't know, even 5 years, is it really going to matter?
I think we don't know because
This might
we don't know
enable-
the users of this yeah. So
Yeah.
Well,
yeah,
there
so-
is ZK
so-
Sync.
yeah, I'm in touch with them, but I sent them email and also asked them to join the call, but not sure if anybody from them joined. Sorry, I cannot see the list of the attendees. And yeah, so I can only wait until they answer, but we can also try to reach someone else. Yeah.
Another question that might help to solve this is, let's say we launch with subgroup checks. Would it be possible in the future to keep the precompile ID and remove the subgroup check and add it separately? Like, would it break people? If the contract didn't work before, I assume that with the subgroup check, they won't deploy it because it would be it wouldn't pass the subgroup checks. And for those that work, well, they would need to modify the contract to explicitly do the subgroup check. But I think it might be forward compatible to add them later and remove them from the original precompiles.
You mean add as a separate precompile later?
Yeah.
Yeah. I mean, I think we should try to keep the ABIs the same. So it would be weird if you had written a smart contract that, has some knowledge of this bit for turning them off or on, and then yeah, in a future hard fork that just becomes invalid. Although I guess you could ignore it.
I mean, without a flag, without a bit, like
Yeah.
you just keep the precompile as is.
Okay, but then so why do we do this? Because we deployed it. It turns out this was way too insecure, and so we need to fix it in a later hard fork.
No, I think it would be that it's deployed with subgroup checks, and then people are like, "This is too expensive," and then I guess you remove it, and then everyone who was previously deployed is still safe. It's just that newer contracts now need to explicitly do the subgroup check. Is that right, Mommy?
Well, I'm not sure if they are safe because previously they might need to be modified. That's but I mean, the question is more,
Alright.
can we do something today so that we can keep we can be forward compatible if we decide to do subgroup check separately?
Oh, I see. Okay, yeah, that's correct. I guess the only way to do that would be that the contracts deploy today, and let's say we add a flag, and that flag always has to be true.
Okay.
So they get the option to put a flag in, but it just always has to be true. It just means that if you change the behavior, then it doesn't break their contract once it's like once you allow false.
Mm.
Yeah, it's a bit hard to make a decision because the use cases or the users who will be using it are sort of not present.
Right. So like, yeah, who would be good to talk to then? Like ZK Sync. What about like Scroll or maybe even Tycho?
Tycho is using it would be more like SP1, Risk Zero, because Tycho is integrating them basically.
Okay.
Yeah, as a joke, we have also additional options. So to postpone it and wait until the EVM Max will be ready and implement everything in EVM Max.
You mean postponing the EIP?
Postponing the EIP because
Again?
again, but do we really know who really does need it, and why
I
why
think
we adding this?
if you look at I think it's one of the EIP where people are always asking, wow, this has been proposed in 2020. It was almost shipped and actually shipped in parity by mistake in 2021 in Berlin. And yeah, people really want this,
So
if only to have MSM available as a precompile.
yeah, so let's reach out to these people and ask them if this this specification is okay for them, and we can decide if the subgroup check is needed or not, and we want to implement this other way,
Because
yeah.
one way to view this is that whatever we do, uh, whether we use subgroup check or not, it will be much faster than doing things on chain at the moment. So yeah, and maybe we can just sweeten the deal with gas price.
Yeah, that's also an option, or to at least for now implement the precompiles which does not require which don't require the subgroup check, so they cannot use the super fast algorithms, and then with this additional flag, for example, which now is 0, and then allow people to define a flag which will mean that that the subgroup check needs to be done before, something like that. I don't know.
Kev, to answer your question, is slower than BN254, but the BN254 gas price is very overpriced with the current state of pairing library speed. And yes, there is a security argument of the number of security bits of BN254, which is kind of inadequate today.
Is it only the pairing that's overpriced?
Not
BN254?
only. Let me look at my.
I think most
Because
of them were. I have a PR on GAF that switches out the Cloudflare implementation, and I think it's like a 10x for some of them, but all of them have an improvement.
Wow.
I think I think everything was overpriced on the BN254 precompiled cost.
I ask because I feel like there was already years ago there was already a repricing to reduce them by a large factor because I think like Zach Williamson implemented EC-Mol cheaper on chain.
Yeah, with
But
via Strudel.
okay, so they're still very slow.
But
then.
that was already back in 2019 or 2020. So it was 5 years ago.
I guess the point is that people are currently using BN254, like the rollups, and they're not doing it sort of inside of the EVM. And I guess if this is too expensive, do they still stay on BN254? There's a security argument, but I don't know if most of them have brought this up. Like, do they really care about the security argument right now?
I would hope so. So I don't know. Yeah, like I think there's grounds to ship this curve in the EVM. The security argument is one. Again, also I think the BLS12 curve is just sort of a newer curve that more people are using. And also there's a very important use case again of the consensus layer. So I think, I mean, yeah, I don't think we should really dig into shipping this precompiler or not on this call. But yeah, I can try to get in touch with some of the people we listed and figure out like API wise what makes sense to them. Another thing to think about or ask then is, are there other questions around the gas benchmarking that we have? I think there might have been one around the MSM and how it works. Because there's a question of like multi-threading and then how that bundles into how we think about benchmarking the gas cost.
What were people's thoughts on multi-threading? I think Jared mentioned that you're going to ship with multiple threads, but benchmark on single threads. And I think EVM1 said,
exactly. I think the Geth team thoughts were along the lines of it being hard to have a benchmarking environment where you can accurately simulate, like, so when the node is running live, we don't just have it's noisy, right? The CPUs may be like drawn in for other things, and it's hard to replicate that in a benchmarking environment. And then yeah, I think just beyond that, it's just work that is not paid for by the gas model.
right. I guess one consequence of this is that there is no rationale to then decrease the gas costs in the future, right? Because let's say all nodes go up to like 8 cores. Because we're only ever benchmarking on a single core, even if MSMs become twice as faster in production, you can't argue to then decrease their costs, right? Because on a single thread, they're the same.
Yeah, sure. Yeah,
I mean,
definitely.
if we're thinking about the worst case, then, even if you have 8 cores, it could always be that, they're busy doing other stuff. So for the worst case, I think we'd still have to think about the single core performance. Yeah, we did the same thing for benchmarking as well. And MSM runs very slowly with 1 core. Like I think based on those results, we have to increase it, but without the subgroup checks, it seems fast enough even on 1 core.
Okay, I see. And I guess just out of curiosity, if someone was to push an MSM algorithm that was fast on a single core, meaning the latency was pretty low, but on multiple cores it wasn't fast, how do we gas benchmark that? Like it's slower in production because it's not made for multiple cores.
Fast on one core, serial, and slow parallel.
Right.
I think today it would be safe to, let's say, bench on 2 cores, because even the Raspberry Pi 4, which we kind of memed when launching the consensus layer, was already 4 cores. So this brings the question, what is CPU, the earliest CPU that we want to support? The slowest would be Raspberry Pi 4, Raspberry Pi 5, that we kind of use to do we want to make the Ethereum decent on this hardware?
So I think Mark and Jared were saying that even if you have 4 or 8 cores, they could just be busy doing other stuff.
Yeah. This happens when you, for example, you sync and you have some cores that do gossip, but at one point they get stuck waiting, like maybe the processing is waiting for the network, or the network wait for the processing to be done as well. But I guess for me, I prefer to bench on 1 or 2 cores to be conservative.
Another data
Also,
point here is the sort of like standard machine that we do all of the DevOps testing on is 4 cores. So I believe I left a comment to that point on the PM repo, and yeah, that was kind of where that was coming from.
But if you bench with Go, you can add -- CPU 1, and it will run on a single core.
Right. Yeah, no, I mean, we can bench with any number of cores. The question is like, how many do we want to target? And like, yeah, I guess there's a question of like, well, yeah, okay. If your other cores are busy, that's a complicating factor, but that's really hard to predict.
yeah, Kevin, in response to what you're saying about if there was a version that was slower with multiple cores, I think we would still just have to think about the worst case. So whatever's worse out of 1 core or like multiple core scenarios, just like the worst of all cases, you have to price based on that.
And Mark, you're saying that there was an issue with the subgroup checks, like that was relevant to the benchmarking that you've done?
Yeah, so benchmarking on 1 core with the subgroup checks is MSM is too slow. Sorry, G1 MSM specifically is too slow. So if we were to disable it, then that would bump it up to sort of an acceptable level. Or alternatively, we could just increase the price and keep the subgroup checks.
Yeah, so in my benchmark, it's a G1 MSM with 2 inputs. I was doing 120 megagas per second, and with 128, it fell down to 40. So yeah, it wasn't scaling as expected. While pairing for BN254 was always 200 megagas per second. So the formula was really good for this one.
Yeah, but for pairing, for pairing input, you don't do the sub. Sorry, you do the subgroup check only for the second point. Yeah, from G2.
You have to do subgroup check for every point with pairings.
Yeah, but for G1 in pairing, the group is equal
Oh, yeah.
basically the points on the curve. So for G1. So but of course for G2 you have to do the subgroup check for multiply.
even the BLS 12381 pairing precompile has good pricing. It's constant, even up to 8, from 1 to 8 points. It's just that it's a bit highly priced because I do 220 megagas on a laptop CPU.
Okay. I guess where I'd want to start from is if we have, the precompiles, mandatory subgroup checks, and even on a single core. It sounds like if we do this, then it sounds like the EIP is out of date in the sense that some things will need to become more expensive gas cost wise. Does anyone know what those numbers would look like?
I give some in the price suggestion question. I can relink directly to the to that part.
Okay. Because then from there, I would then try to get, one of these ZK rollups to just give us like sort of a test vector of what they would expect to like how they would expect to use this. And we can get final numbers on the actual gas cost. And then, it could be the case that this is fine and we're good. If it's too expensive, then we can think about ways to make it cheaper. And that seems like the way forward to me, because yeah, it just sounds like there's too many unknowns to really make a call right now. Does anyone disagree with that approach?
Yeah, I think maybe my preference would be to increase the price of G1 MSM and then maybe just add these a flag, even like if it's just a dummy flag to MSM and pairing, to have the option maybe to disable it in the future, even if we don't implement it now.
Yeah, that's reasonable. I wouldn't want the precompiles. I mean, yeah, the main thing there is just like the more we have, the more complex they are, the harder they are to test, and then it starts touching on like hard fork timelines. So
It's also a pain to implement in ZKVM if you do flags. Because one thing I forgot is that when you do a ZKVM or EVM, you have to prove all the possible paths. So if you implement the flag, you'll have to do both with and without subgroup check for in the ZK EVM a circuit that does both, which is complex.
Okay, so I guess equivalently, if we just kept things as they were, then we could always just add an identical operation or identical operations without subgroup checks, and that would have the same effect.
That's true. But it means we have more precompiles. I'm not sure how comfortable people are with adding 4 more precompiles.
Well, I mean, if we're worried about the number of precompiles, then we could always get rid of the scalar mul. And then we could just add the 2 more, and then that would be the same amount of precompiles overall.
So I think it just becomes like a timing question. Like if we get to a point where we're ready to ship Pectra and this EIP is holding things up, it will be pulled out. So I'd rather like not really touch the high levels of this EIP at the moment. At least personally. And then I guess in that case, I would kind of want to think about this other option of relaxing constraints in the future. So that, yeah, maybe if it becomes an issue, then we can say, okay, for the precompiles we have that are already deployed, you can take the subgroups out, and we also have the option to have, yes, possibly other precompiles 4 subgroup checks, and I think that would also work in terms of the forward compatible notion we were talking about earlier.
Yeah, I mean, I guess the only thing is you'd have to be careful about removing them when contracts are being built, kind of assuming that they're there, which is kind of why I prefer the idea of having identical ones that are different. So they're just sort of a drop-in replacement.
Yeah. Right. So then maybe we should ship without subgroup checks. So people don't get used to them.
But then people will some might make mistakes and
Right.
blame us.
Yeah. No. Okay.
Can't people use like what are they called? Like Open Zeppelin libraries? Like EC Recover, I guess, also has some foot guns that, and isn't a recommendation to just use Open Zeppelin?
But it's extra mental load to be aware that you need to use checked arithmetics for you into 5.6, be aware that you need to check, etc. And at one point where people are trying to get their audit ready, they forget things. If they do the audit, or sometimes they just ship to production and it's the intern that pushes the button or whatnot.
Yeah, I guess that's fair. It's just that when I think of anyone using these precompiles, I think of someone who knows what they. I guess I don't know who the use case that the users are. Yeah.
But if you look at, for example, let's pick Monero. Monero dev they know cryptography, etc. And back in 2017, they had a bug that could have broken their blockchain because they missed subgroup checks.
So we're almost at time. Well, also, by the way, that's very scary for Monero. We're almost at time. So I will do my best to find people who give us somewhat of a target in terms of things we should actually build towards, like use cases. I would then try to take the most conservative approach that I laid out, essentially saying, yes, there are subgroup checks that the precompiles do. We're on one core, and then kind of go from there just to see, if it's actually too expensive for the users we have in mind. And I think that will give us more information to know which direction to go in. Yeah, does that sound okay to everyone? Okay, cool. Any other closing comments?
When next breakout? Then
Yeah. Well,
2
okay,
weeks.
so
2
what
weeks.
what can we do? It sounds like we can think about updating the EIP, right? Because it sounds like the EIP is a little out of date with this sort of set of constraints that we agreed on. That's something we can do.
And I think also trying to find some formulas for MSM, well, for the costs of everything would be helpful as well, so that we can discuss specific formulas for the repricing, the gas price.
Do we need different formulas?
Well, for MSM, the scaling is wrong. For pairing, the cost is too high. And I think it's fine to focus on BLS 12 curve because even if they end up priced lower than BN254, this will encourage people to switch, which is a bonus for security.
Right. I mean, yeah, I'm not really thinking about the other curve. But yeah, if it was somehow more attractive, say economically, that would be great.
So do we want to target EC recover then as when we're coming up with these gas cost formulas?
For me, I worked with like a target million gas per second and try to price to get those. Assuming like a laptop CPU from trying to get good performance on a CPU from 5 years ago, let's say.
So, I mean, there's also other precompiles than EC Recover that we could potentially base this against to get a wider range of comparison. And I think you were mentioning for Besu that there were issues with the granularity of EC Recover in terms of the overhead of FFI.
Yeah, actually, we bumped our version of SecP-256K1 recently, and that gave us a little bit of a performance boost there. And really, I think some of the benchmarking test suites that have been pointing fingers at Besu's EC Recover performance are perhaps not as accurate as they could be. And we're seeing pretty consistent EC Recover performance, so that's why we went ahead and based our initial cut at the MSM gas costs off EC Recover.
Cool. I think Geth is fine using EC Recover as a base. But yeah.
We are at time, and at least I have to hop. But yeah, hopefully this was helpful. And yeah, we'll at least get to this on the next ACD, if nothing else. And then from there we can coordinate on if we need another breakout or not.
Okay, cool. Yeah. See you
Later.
guys.
Okay,
Yes,
bye.
Thanks. Bye.
Thanks.